All right, so let's look at module 2 now, where we get into the DevOps lifecycle and do a case study based research, do some hypotheses, go through in detail what the DevOps lifecycle is, and then look at some real life examples from the industry as well. Okay, so here's the famous DevOps infinity loop. This is called an infinity loop because it defines the delivery pipeline that allows development teams to build and deploy software continuously in an iterative manner. And it's called infinity loop because there is no such thing as a start and an end. And typically this loop will start from the plan phase. That's the agile planning phase. And then based on the agile planning and the features or the bugs that you have planned to fix or implement, you would code them, then create the software build for that, then do various sorts of testing, including your unit test, your functionality test, your performance test, things like that. Then you would release that piece of code onto productions from where the end users start using it. As part of that release, you would deploy it into different environments, and then you would get into the operate phase or the operations phase, where you start doing things like you start monitoring it, you start looking for feedback, and the feedback that you gets back into the planning phase. There might be defects, there might be suggestions for improvement to the software, and then from planning, then right back to coding, and then thus the infinite loop starts operating again and again. So that's why it's called the DevOps infinity loop. It's a very famous terminology used worldwide in the industry. So let's look at some standard definitions of continuous integration. Now, this definition is by a person called Martin Fowler, who is very famous for doing a lot of research. He's a fellow at ThoughtWorks right now. And this is how Martin Fowler defines continuous integration. And it's one of my favorite definitions of continuous integration. A software development practice where members of a team integrate their work frequently, which means they check in frequently into the code base. Usually each person integrates at least daily, leading to multiple integrations per day. What that ensures is that my code merges with the code of my fellow developers, and any dependencies within my module, across my modules, across modules, dependencies with third parties, those are getting sorted as soon as possible. And each integration is verified by an automated build, including test, to detect integration errors as quickly as possible. So the idea is to take a bigger feature, take a bigger defect fix, break it down into smaller components, smaller pieces, submit the code for that small piece multiple times a day, automatically build it, automatically test it. And what you're trying to do is basically left shift of everything, detect integration errors as quickly as possible. So that's in a nutshell what is continuous integration. Now let's look at what is continuous delivery. It's a software development discipline where you build software in such a way that software can be released to production at any time. What does that mean? That means at all points, your software has been continuously built, continuously tested, and if required, it can be released to production at any time. Doesn't mean each iteration will be shipped into production, but potentially it can. What that implies is that your entire software delivery lifecycle has to be so matured that the moment you're checking in code, a lot of things have to happen automatically, including building it, including deploying it, including various sorts of testing, so that if all of these stage gates pass and you achieve the quality that you're expecting it to be, at that time, you can potentially ship to production. That's the textbook definition of continuous delivery. And as we go further into this module and the other module, we will see the technology architectures behind continuous integration and continuous delivery, and some case studies of how we have implemented this. And then coming into module 3, we will actually build a software pipeline where we will do continuous integration for an open source project and a continuous delivery. So moving into Agile. Agile is an iterative approach for project management and software development that helps teams deliver value to their customers faster. Now, everybody has an idea of what Agile is. And the basic idea of Agile is, instead of releasing one big software at the end of 6 months, 1 year, instead of a big bang launch, you launch smaller increments, giving continuous value to the customer, and also getting early feedback from the customer. And then that feedback is acted upon and again delivered to the customer. So that's the whole concept of Agile. So let's talk about going from Agile to continuous integration, continuous delivery. How does these two fit in together? And as you can see, there are 4 dimensions to this. We've spoken about Agile and DevOps. So you typically start with Agile development. That's where you get from a product stage where you're sort of defining what you want to build. That gets into the backlog, the final product, the user inputs, all of that is the Agile development stage. Second is the continuous integration, where the developer commits code into the code repository. You have the CI server, building the code, doing a unit test, doing code quality, the repository manager holding the artifact binaries and the code quality metrics, which will give you the health of the overall deployment and the continuous integration system. Number 3 is continuous testing, because at each stage of this, you are doing various sorts of testing, be it integration testing, UAT testing, testing from the people on the field, performance testing, functionality testing, database testing, a whole lot of those kind of things. And then finally, leading on to continuous delivery. Now, continuous delivery ensures that products gets into the customer's hand as soon as possible. And to enable this, we are even talking of things like infrastructure as code, which ensures that the infrastructure on which we are building also operates in the style of source code, so that there are the maintenance and the upkeep of infrastructure is treated like we treat the maintenance and upkeep of the application. So that's the correlation between Agile, which is talking about incremental deliveries. For those incremental deliveries, you make frequent commits. For those frequent commits into source, you do continuous integration, you do continuous testing, and then you do continuous delivery. That completes the loop. The feedback again goes back to Agile development, and then the cycle continues. So in this, you can visualize the infinity loop that we spoke about, and this is a technology view of that infinity loop. Now, going ahead, let's look at from a more technical standpoint of what's continuous integration and continuous delivery, and how these two things start merging together. So on the left-hand side, there are a bunch of developers, and they are working on fixing a defect or working on a new feature, which is supposed to be released soon. And for that, they produce some code and check it in the version control. Now, a continuous integration server, this could be the likes of a Jenkins, is continuously listening onto the version control system. It detects a change by one of these developers, and then it creates build artifacts. Now, the build artifact in a Java world could be a jar, var, a zip file, any sort of binary file, some config file, some database changes. These are all called build artifacts. Now, these build artifacts get deployed into various places. If you just take a simple 3-tier application, there's an app server, there's a web server, there's a database server. So this part of the developer working on a change to the continuous integration server producing build artifacts That's called continuous integration. And then the next part where these artifacts are deployed onto these servers or the payloads, that's called continuous delivery. Now, let's move ahead and see how the evolution of continuous delivery came about. So about 15, 20, 25 years back, we had simple applications with one app server, one web server, one database server. As the software complexity increased, we realized that one app server ain't going to cut it. We need multiple app servers, multiple web servers, multiple database servers. That was to take care of the complexity and the scale of the application. So instead of one app server, we had 4 or 5 app servers. Similarly for the web and the database also. And then as that started getting more complex and more matured, we figured out, why would you even have the entire machine serving just an app server? Is there a way to shrink that? Because then you started hitting hardware limits on your data center. So to be able to virtualize this, we came up with the concept of container virtualization. So what does container virtualization say? You don't need the whole server set here, whether virtualized or not, but you can extract the entire machine and get it down into bare binary. The infrastructure might be on a laptop, might be in a data center, might be on a cloud, but you put a hypervisor layer and a Docker engine layer on top of that, and then you start building containers. And the containers can hold a web app, an application, or a database. So that's how the container virtualization started happening. And then as this world started getting complex, as we started building hundreds and thousands of containers for applications in the cloud or in the private data center, we came across the concept of container management. How do you manage hundreds and thousands of containers? How do you scale these containers on the fly? That's where things like Kubernetes, Swarm, Mesos, Rancher came about. And then as that ecosystem started getting matured, the question popped up, why should I have to worry about which container holds which application? Can I just abstract that layer also? Can I let the cloud provider manage all of that? And that's where the concept of serverless came about, where I don't have to worry about what server my particular piece of code is running. It is serverless. I don't care where it's running. I just tell it what horsepower it needs. And then the application, the cloud provider will give me that horsepower, and I will run that application automatically. So that's kind of been the evolution of CI/CD. Now let's get to the next one. Where's the cloud in this? Pretty much everywhere, as you can imagine, right? So the folks which are developers, they can be on the cloud because we have today in the cloud a complete developer setups which can be accessed from a dumb terminal, and everything can be on the cloud. Of course, the version control, things like GitHub, they're all in the cloud. All of these continuous delivery servers and so on and so forth, all of these layers can completely be on the cloud. And you go to any modern startup today, you can have a very, very complex piece of software running completely on the cloud with zero or bare minimum physical hardware. That's possible in today's world. So let's have a look at the periodic table of DevOps tools. This would give you a view of the complexity of the tools out there. This has been created by digital.ai. If you just search for periodic table of DevOps tools on Google, you will get it here. What we are talking about is basically a collection of various tools in relation to the kind of tools they are. For example, this green one is cloud. So you check that out. It's AWS, IBM Cloud, OpenStack, and things like that. So you can pick up any one. For example, this purple is deployment, which is Azure DevOps Pipeline, digital.ai deploy, Urban Code, Harness, Spinnaker, which was created by Netflix, Octopus Deploy, and so on and so forth. So it gives you the tool set based on the category of tools that they are. Very useful information. Another way in which this has been represented is the continuous delivery map. And they have, again, the earlier atomic folks, what they've done is they've taken the London Tube map and they have mapped continuous delivery on top of that. So similar kind of information, but presented in a different way. If you've been to London, if you're familiar with the tube map, you would know what we're talking about here. Then we want to talk about what are the benefits that organizations are seeing when they implement continuous integration and continuous delivery at scale. And there are certain organizations, for example, this particular diagram is taken from the Puppet Labs. They create a state of DevOps report every year. This particular report is from there, and they say that organizations which are in the higher maturity level, they have 440 times faster lead for app updates. They have 46 times more frequent deployments and 44% more time spent on new work rather than on maintaining work or rather than on fixing defects. So those are kind of the benefits that the high achievers in this area have gotten. Let's talk about Netflix. And the reason I want to talk about that is all of us are familiar with Netflix. All of us probably use Netflix at some point of the time. And Netflix is one of the leaders in this area. They run hundreds and thousands of microservices, delivering thousands of daily production changes, tens of thousands of virtual instances, and so on and so forth. The important part is all of this good stuff is supported by about 10 odd DevOps ops engineers and 0 networks ops centers. Why this is important is because not because of the size of the team, because the size of the team is dictated by the maturity of their processes and the maturity of their tools. That is why such a hugely complex and such a reliable service is just supported by a handful of operations engineers. That's the important point to note here. Yep, hopefully you can relate to it. So let's now look at 2 detailed case studies from the trenches. The first one is from a retailer in Europe. And the problem statement was that the retailer was working with a couple of vendors and they wanted to assert back control over these environments because these vendors, this one vendor in particular, had control over their environments, and the retailer themselves were finding it difficult to deploy at will because they had the dependency. Also, the DevOps strategy had to be put in place to drive hyper automation, and that strategy had to scale across the enterprise to establish new ways of working. And in doing that, they had to break silos and get everybody who was working in their own silo, get everybody together to work as one cohesive team. The way this was done is that the first problem of the environment, certain back control, that environment was reversed engineered. A parallel environment was set up as a child environment, and then the mastership was switched. Then once the pipeline was established, then an end-to-end DevOps pipeline was set up, including automated builds, deployments, testing, the ones that we spoke about a little bit, for the front-end stack to start with. And then as that matured, that started getting into practice, and as that started getting adopted, the enterprise started moving from the front end to a pipeline across technology stacks. So from the front end to the Java, to the .NET, to the legacy layer, to their package system for Pega and TIBCO as well, right? And as that started happening, the versions of pipelines started getting matured, and then there was time to standardize things across the enterprise, which meant establishing the DevOps Center of Excellence to standardize the operating procedures and the ways of working and to scale them up. Also, as the development team started maturing and scaling up, there was also involvement of business in the transformation process, because as the dev team start throwing out stuff, code faster, the business also has to start testing it faster. And then as all of that started maturing, we had to recalibrate the enterprise into a custom agile framework, because the team structure had to evolve. Why did the team structure had to evolve? Because as you start moving faster, the old siloed ways of working would not be valid now. Just take a pause here and get my daughter to quieten up. Be back in a minute. All right, so what did we learn? What are the things to take note of? First one, very important, showcase success. As the enterprise moved from one pipeline to pipeline of pipelines, it was very important to showcase the success of this effort. What happens when you showcase success? The developers start believing it, because seeing is believing, and then the buzz starts to move around the organizations. The water cooler conversation starts to happen, and that's when the cultural change from bottom up starts piling up. First automate, then standardize. If you remember what I said in the last slide, we automated the front end first, then moved to other technology stacks, and then went to standardization. Because you prove first, you scale later. You automate first, you standardize later. This is to avoid the trap of doing a massive 6-month standardization exercise without having proven it technically first. Early business involvement, because these kind of DevOps transformation is not just a technology change, it is a change in the fundamental ways of working, which involves business as well. And then restructuring is very important once you reach a level of maturity, because the way teams are structured as individual silos in an enterprise needs to be broken into some form of a squad or a tribe or some variation of a Spotify of a scale framework. Now, every organization is different. So the guideline is don't just pick up a Spotify or a scaled agile and copy paste it in your organization. Chances are it won't work. Take the best from all of these frameworks and then create your own, which is inspired from the success of these, but tailored to your enterprise. But whatever shape and form, restructuring of the organization is very critical. All right. The second one is the story of a bank in Europe. And the problem statement was to accelerate the time to market. It was to enable the digital banking platform at scale. And it was to integrate the front end with on-premise core banking system, and also to reduce the capex on a private cloud vendor. Now, why all of this is important? Because in the banking industry, all banks all across the world are getting a little worried because of the digital native banks which are popping up all across, right? And unless you are digitally mature, it is very, very difficult to survive in the banking industry today because of competition, because of also new laws, new governances that keep coming up and which you have to adhere to as a part of the law. So you need your bank to be fast enough to respond to those measures. Things like GDPR, open banking, that put a lot of software challenges on banks. So what was the approach that the enterprise took? It focused on the tech stacks. It focused on assisting the operations support area on the new roles and responsibilities, because the support operations role was changing from a centralized team which used to serve the entire software development lifecycle, get changed from that to a decentralized team which was embedded as part of each team, and which was going into the philosophy of you build it, you run it, you maintain it. And also retrain them into the new cloud and the container world. What was the build? To build the strategic roadmap for cloud and container adoption. Because when you start moving into these areas, it's a whole new way of building software. It's a whole new way of deploying software. It's a whole new way of supporting software. The traditional WebLogic, WebSpheres of the world do not work here, right? And the way those environments are built and supported, completely different. Also finalize the tool set across the SDLC, because the tools in the container and the cloud world are different. Then automate the automation for onboarding online and mobile banking onto the new platform. Because as these teams start moving onto these new platforms, they have to be onboarded rather fast, ideally even on a self-service mode. And then the third, operate, was to broad-base adoption of the new container and the cloud platform, introduce the support of infrastructure as code through the SDLC. What does that mean? Because your application is cloud native, is container first, the way you treat your infrastructure also has to change. The infrastructure is no longer a fixed set of boxes. It is dynamic. It is built up when you need them. It is toned down when you don't need them. You move into the concept of treat your infrastructure as kettle and not as pets. Don't name your infrastructure and take care of them as they were your pets. It's moving towards the immutable infrastructure, where you create and destroy infrastructure on demand. That means infrastructure as code. The end result of this, 36% faster time to market, 28% reduction in OPEX, and more than 90% infra and config as code, which led to predictability. Because any change in infrastructure is also controlled through your source code, just like a change to application, just like a change to database. Key learnings: POC based, proof of concept based, especially when you're doing toolset selections. Don't go with what you see in conferences, what you read in the literature, because your environment, your infrastructure, your setup could be different, and your needs from the tool could be different. So take the couple of tools that you're thinking about, do proof of concepts 2 weeks, 4 weeks very quickly on those tools, and then see which one is behaving at the like you want, and then select them. What is in it for me approach? This is very, very important, because this moves into the culture change rather than the technology change. So to various people involved in the transformation process, we have to explain it. What is in it for me? Why would a person in the operations team care about DevOps transformation? Why would a test automation engineer care about a DevOps transformation? Why would a developer care about this? Why would a release manager care about this? So clearly explain to them what is in it for me and what's the benefit that they are getting. And that's when they start getting involved in the process. Custom upskill path. Whether you're talking developers, whether you're talking support people, whether you're talking infrastructure guys, when you get into these kind of changes at scale, everybody has to upskill. And creating custom upskill path for your workforce is super important. And that's where the commitment from senior management comes into place, because you might need new software, new pieces to take care of the technology stack. You will need help with upskilling. You will need help with certification. And you will probably at some times need a top-down approach with a few people who are not ready to fall in line with the transformation. That's why the senior management commitment is super important. All right, now let's talk about an exercise. Let's talk about an hypothetical IT company which has adopted agile practices for development, and now they've built a beautiful new architecture for development, and the executives have realized that operations team are still working in distributed teams and tight SLA agreed with the customer multiple years back. The company has decided to do a pre-study to identify potential areas of improvement and adopt DevOps practices. We've touched upon these things briefly in the last couple of slides. What's the outcome expected? You have to think about this and identify key bottlenecks and a proposal to transform the operations integrated into Agile. You have to think yourself as the head of operations team, where you have the responsibility to report in one slide what needs to be done in order to transform the operational setup. So have a think about this, spend about maybe 20 to 30 minutes thinking about it and creating the slide, and then submit the slide for that case study. Hopefully you understand. And that's the end of module 2. Thank you.